a whole virtual universe.
A fully virtual world might still be science fiction, but the technologies behind it have been used in the car industry for years now. At this auto factory in Shenyang, a car is going through the marriage station in production line. That is when the body and the drivetrain are put together. In real time, digital twins of the production line virtualize the process in the software.
When we need to make a change to the facility, like Chantal mentioned, then they can do it in the offline world. Yes. They can program it, test it, and then we have to implement it here, and it works maybe even the first time.
Yeah. So meaning no need the people or engineer be on site.
This means engineers anywhere in the world can work together on an issue and test it in the software before making changes to the real thing.
We will do a little bit of testing, but not near as much as we would do previously. Previously, we would maybe test for days and weeks to make sure you find really every problem in the program. Now you can really find it within a day or a few hours.
Yeah. Because of this program.
Yes.
Another example of using digital twins is the building of the factory itself. Plan Lydia is the first factory within the BMW group that was planned and simulated entirely in a virtual environment from the outset. Virtualization saved 6 months of planning and construction time. This technology is increasingly being adopted by manufacturers of complex machinery, builders, and city planners. In a central document, the Chinese government encouraged using digital twin for building smart cities. Analysts project the global digital twin market will be worth hundreds of billions of dollars in the years to come. For plant director Zhang Tao, digitalization is not an icing on the cake, but key to success.
If we want to have very good position, market share, that we must further improve our efficiency and quality. Big data and digitalization transformation support a lot to continuously improve the efficiency. And regarding the quality, we very often talk about the zero defect. Without digitalization, it's impossible to achieve it.
Zhang took me to the plant's brain, the control room, where algorithms are constantly calculating the risk of something going wrong.
You see this the green line and the blue line have a little deviation. This message already sent to the engineer. So therefore, we use every big data to predict the trend of the issues, then solve it immediately to avoid further worse our equipment breakdown. So this is the value of digitalization, our big data.
The operator says the system has helped reduce preventative maintenance, thereby increasing efficiency. Logistics is another important process for a car factory.
So this is why we have the real-time monitoring system.
This tracking system is possible only because various entities on the supply chain share data with each other. Industry analysts also see breaking data barrier as crucial to promoting sales models of the auto industry.
Even though we have a lot of data available in the auto industry, we can see that a lot of data is actually not in the OEM side. It is actually in the dealer side. The dealer OEM, they are different legal entity. If we see the sales model, the business model are more embedded with the digitalization, and there is a transformation for that business model, the state of digitalization will be more mature.
Zhang Tao believes digitalization is one of the key drivers to the new quality productive forces. As a CPPCC member, Zhang has submitted her proposal on various aspects of promoting digital transformation of industries to the central government during the annual political gathering 2 sessions. Zhang believes digitalization is the key to enabling the kind of innovation that China is focusing on to develop new quality productive forces. She hopes that the best practice of digitalization in her plant can be shared with others, and all the companies can learn from each other while traversing the path to digital transformation.